so these are some questions from the test review in your similar triangle packet. We're starting with problem number 8, and it says find the geometric mean between the numbers 8 and 12. And so when I hear the word geometric mean, I know I'm going to set up a proportion. Where does the x values go? Bottom left and top right. And it's between 8 and 12, so we're going to put the 8 and the 12 here. Anytime you have a proportion, you know you're going to do what to solve it? Cross multiply, good. So I'm going to have x squared is equal to 12 times 8, which is? Okay. Now at this point, I'm going to take the square root of both sides, and I'm going to need to reduce the square root of 96. Now if you leave it, if you leave it like this, I will give you most of the credit, but not all of it, because you do need to reduce this radical. So I'm going to take 96, I'm going to make a little factor tree. What are some numbers that go into 6? Well, 8 and 12. Let's use the numbers that we multiplied. Perfect. And then we'll just keep going until we get all prime numbers. Factors of 8 are 4 and 2. Factors of 12 are 6 and 2, 4 and 3. It doesn't matter what you pick. Oh, thank you. 6 and 2. And then we'll keep going. And I like, if it's prime, I'm just going to bring it down anyway, just so I have everything kind of together. And what am I looking for? Pairs, groups of 2. So I have one group of 2 is going to come on the outside. I have another pair that's going to come on the outside. And then everything that's left is going to go on the inside. And 2 times 3, I'll just write it out, but you know it's going to be 6. So I have 6, and then I have a, sorry, I'm jumping ahead of myself. I have a 6 underneath the square root and a 4 on the outside. So that's going to be the reduced final answer. Okay? Helpful? So 9 is very similar. These would be questions in the similar right triangle section, because if you remember, like question number 10 and question number 14, which I'm only going to do one of those two, so I will do 10, not 14, because they're the same type of question. But those are all geometric mean questions. So I'm not going to do 14, but I'll do 10. I'll set it up 14 for you. X is the geometric mean between, and 14, 12 and 9. So that's just the proportion there. Let's look at 10 though. Okay. So 10, I have a picture. And this is it. The mistake that so many of us want to do is we always want to say that x is the geometric mean. But in this case, it's not. X is not the geometric mean in this case. Remember that when we are looking at a picture, these 3 segments are the geometric means, the 3 altitudes that come from the orthocenter. Okay? So which one of those numbers represents the actual geometric mean? 10. So 10 is what's going to go here and here. Okay, not x this time. This is an unusual one. It's different. And what is 10 the geometric mean between? This is when I kind of draw my little curve between the part that it touches. So, Sophia, go ahead. Perfect. Between x and x plus 15, because it's between the part of the hypotenuse it touches and then the entire hypotenuse. Good. At this point, I'm going to cross multiply. And when I do that, I notice that it's a pretty difficult question, because what do I have to do with the x? Distribute it. And when I do distribute it, it becomes what? Quadratic. So I have x squared plus 15x. I'm going to go ahead and move the 100 over. Is that okay? Why? Why do I want to do that? Sophia, go ahead. And when we have a quadratic equation, we want to make sure that it does in fact equal 0. Now yesterday afternoon, I think we either did this problem, one very similar to it, and there were really 2 ways that we could have solved the quadratic. Do you guys know what those 2 ways are? What formula is it called? Do you remember? The quadratic formula, right. Have I ever sung it to you before? Do you want me to sing? No, you really don't. But I'll do it anyway. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. You're welcome. That'll be stuck in your head forever now, right? X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That is the quadratic formula. You may or may not choose to use it. I happen to think factoring is a heck of a lot quicker, but the quadratic formula will always work, so you can use it. But we did it yesterday afternoon, and actually it became a lot more work, if you remember. So I prefer to factor, but if you are a quadratic formula person and you know you can do that well, then go on. Go for it. I applaud you. But this is a factoring question that's really, it's quick to factor, okay? I know that because my leading coefficient is just x squared, that my factors are x and x. The two numbers have to multiply to be the negative 100. Since they're multiplying to be a negative number, one's positive and one's negative. They also have to add to be positive 15. So I'm just going to come up with factors of negative 100. I'm just going to write a whole bunch of them down. So I have negative 20 and positive 5. I have 20 and negative 5. I have 10 and negative 10. I have 25 and negative 4. I can keep going because there's lots of factors of 100. But any so far that add to be positive 15? Yeah, this one right here. So if you're stuck, just list the pairs out and figure out which ones add up to be the middle number. So positive 20 and negative 5. So that's the correct factoring. Now, yesterday we also went over, and your algebra teacher might have shown you this last year, if you're trying to figure out how to actually factor this when your leading coefficient is 1, because it only works if the leading coefficient's 1, I can plug that into my calculator, x squared plus 15x minus 100, and I can graph it, and I don't want a table. The graph shows up too, but the table is quicker for you guys. And you can see that 5 is one of the zeros, which means x minus 5 is a factor. 5 is the solution, right? X equals 5 is the answer, because when I set that factor equal to 0, I do add 5 to both sides, right? So x equals 5 is one of the answers. And then the other one would be negative 20. So if I go ahead and scroll up, keep scrolling until I get negative 20, it's going to be here for a while. Get that as a 0 too, okay? So, but what do I know about negative 20? Why do I cross that one out? Because x is a length, so you don't want a negative value. So if you want to use your calculator to help you factor, that's fine, but I want to reiterate, the table way to do it, if your algebra teacher showed you that last year, only works if your leading coefficient's 1. Okay. Helpful? Hopefully. Okay. What other questions do you guys have? Let's see. 15. Let's look there. So question 15. This one looks to be a little challenging as well. We have a series of parallel lines, and we have some lengths. Somebody tell me what the name of the theorem is I'm going to use here. Say it louder. Say it louder. Side splitter. Come on, be proud. You know what it is. It's a side splitter theorem. Are they the sides of what I'm looking for? There's nothing on the bottom, right? There's nothing on the parallel lines itself. Because if that's the case, if you remember, if I have something that looks like this, where I'm given like 9 and 4 and, I don't know, x and 2, where 4 is this, and 9 is this. I can't do that problem. Do you agree? This way? I can't do it. They have to be the actual sides. Okay, so what's the proportion? Whatever what equals whatever what? Is that the only correct proportion that will work? Could I have said x over x plus 4 equals x minus 2 over 9? Sure. I tend to go down as well, but either way works. I'm going to cross multiply. What's wrong with what I have over here? It's not really wrong, but what's difficult about it? I've got x's on both sides. I agree that might make it a little harder, but what's difficult about just the right-hand side? What do I have to do? FOIL it. I got to multiply that, exactly. So I have to multiply two binomials together, and when I do that, and Harriet's right, I'm going to go ahead and FOIL that. So x times x, x squared, x times 4, positive 4x, negative 2x, and negative 8 equals 9x. What now? It's quadratic, Jared, right? So when it's quadratic, I got to do what? Get everything to one side. And I like that he wanted to move the 9x because you wanted that leading coefficient to be positive. I'm going to combine the negative 9x with all of the x terms that are already over there. So I have 0 equals x squared. 4x minus 2x minus 9x is minus 7x. Again, if you want to do the quadratic formula, my hat's off to you. Go for it. But I'm a factoring girl. Is my leading coefficient 1? I could use the table on the calculator to help me if I wanted to try to factor it that way. I could also simply list all of the factors of negative 8. They are negative 8 and 1, 8 and negative 1, 4 and negative 2, negative 4 and positive 2. Is that it? Any of those add to be negative 7? First pair. So I know that my factors are x minus 8 and x plus 1. Go ahead and set each of those factors equal to 0. And I can cross out the negative 1 because, again, we're dealing with the length. I will tell you that on your test, there's not a ton of these factoring problems, okay? There are some, but not a ton of them. Really, the geometry is what I want you to be able to do. Can you set the correct proportion up? Do you know what the side splitter theorem is really telling us? Okay, it's just the MYP part, the advanced part that we're doing with all the factoring. Okay? How you doing? How you doing? Doing okay? All right. Joey, he's an old man like me. Okay, 19. Let's look. Here is what I absolutely do not want to see on question 19. And somebody has it on their paper. How many of you had that on your paper? It's wrong. Okay? Incorrect. Angles. So it should be on the inside. Okay? Key word is angle, so you know you're talking about the interior angles of this triangle. What's wrong with my picture? Go ahead, Jared. Yeah, we know something about angles in a triangle. They're supposed to add up to 180. And when I add 7, 11, and 12, I do not get 180. So what do I do? Well, this is kind of like the model, right? We know it's like a scale factor. If we multiplied all those by the same number, some scale factor, then I would get the actual triangle I'm looking for, right? So I don't know what that scale factor is, but if I multiplied by the x, that's whatever that scale factor is, I would get it. So now what's my equation to solve for x? Knowing what Jared just said, Emily, what's it going to be? Perfect. And once I solve for x, then I will know what my scale factor is, and I can put that into the problem and find all the angles. Okay, so I'm going to add them up. When I do that here, I get 30x is equal to 180. Divide by 30, x is 6. So the scale factor here is 6. I need to multiply. So the actual triangle, again, not drawn to scale. Please don't think it is, because it's not. It's actually backward scale. But 12 times 6 is, okay. And then 11 times 6 is, and then 7 times 6 is. Okay, so that would be the correct answer. Yes, sir. That's what I did. No? I don't understand your question. I'm sorry. Oh, you mean to scale? No. I mean, I didn't draw mine to scale. Yeah. Sorry. Yes. No, not to scale. It's okay. You can tell mine 72 is way too small. Okay. Not to scale. All right. Let's see what else we got. I think we're on the back now. 19, 20, and 22. We just did 19. So 20. All right, and problem 20, I got a little problem with the way it's drawn. And maybe you do too, I don't know. But let's start with it. So I have my little tree. I don't know how tall it is. And I know that this is 30. I know that this is 3 and this is 2. It does say a stick is put in the ground, and let's hope the stick isn't put in at an angle and it's perpendicular. Do I have similar triangles here? So we know they both share this angle, right? And we're going to assume that these two are going to be perpendicular. So if they're similar triangles, to me it makes more sense to actually draw the two triangles separate. Okay? Separate them. If you're dealing, we're not dealing with side splitter here. We're dealing with similar triangles. So it's a good idea to split them. And again, we have by angle, angle. They are in fact similar. Okay. So what do I do to solve for x? And there's a couple of different ways to set that proportion up. But you said 2 over 30, Jesse, and then what? Oh, 3 over 30, sorry. 3 over 30, and yeah, that's one way to set it up. I probably would have done it differently. I probably would have said 2 over 3 equals x over 30. But it doesn't matter. As long as you're being consistent. What would be wrong is if I flipped this and said x over 2, because that's not right. Because 3 over 30, I started with the smaller triangle, so like this would go small over big, right? And so that's what we didn't do. We have to be consistent. So 3 over 30, and then it would be 2 over x, and then you would just cross multiply and solve. But I think this one, really separating the triangles and drawing the small one and drawing the big one is a key there. Okay? Okay. On the proof, you can use your reason sheet, okay, if you want. Number 1, what's the reason always? Okay, so please get that one right, okay? Now, the last reason, what would the only choices I have when it says the triangles are similar? What's the only reasons I have? I have 3 choices. What are they? Angle, angle similarity, side, side, side similarity, and side, angle, side. Those are my only choices for reason 5. Okay? And please make sure you're saying angle, angle, similarity. Side, angle, side, similarity. Because isn't side, side, side for congruent triangles a little bit different than side, side, side for similar triangles? So you want to make sure you're being specific there. Okay? So let's see which one it's going to be. So let me just draw the triangle here. All right, so number one we know is given. It says PNO and LMO are right angles. How do I know that? What's reason number two? Go ahead, Asutse. Exactly. If you look at your given information, it says the lines are perpendicular. Anytime lines are perpendicular, they form right angles. Perfect. So I'm saying that the angles are right. Then in statement three, it says they're congruent. By the way, it should have a congruent symbol on number three, so put a little squiggly line over that equal sign. It's a typo. Okay, should be congruent sign there. Not a similar sign, but an actual congruent sign, equals with the squiggle on top. I can't hear you, honey. Go ahead. You need to go get a pass and go to the restroom or something. That's fine. That's fine. All right, so why are the right angles congruent? What's the reason for number three? Yeah, all right angles are congruent. Exactly. Anytime you have perpendicular lines and you're trying to get congruent right angles, it takes you 3 steps to get there. The lines are perpendicular, they form right angles, then the right angles are congruent. Step 4. Why is angle O congruent to angle O? Reflexive. So that would be an easy given. Hopefully that's not a given. Sorry, given's number 1, but it's an easy answer is what I meant. Now, so I have angle O and then I have right angles. What's the reason the triangles are similar? AA similarity. So make sure that you're writing it like that. Okay? Good? 22, y'all need to take some notes because you're going to have one very similar to this on your test, but it requires a lot more work than any of you have on your paper, guaranteed. And I want you to be able to get full credit. And it requires a lot of work. Okay, that's one way. There's actually a couple of different ways to solve it. And you're going to need to be clear with your explanations on this one. So let me tell you what I mean here. All right, so in this problem, I'm actually going to graph it first. It says A is 0, 0. And then it says B is 1, 0. And C is 1, 2. D is 2, 0. Good grief. Did I do that right? Yep. And E is 2, 4. It's a little hard to see, but it looks something like that. You agree? We have triangles ABC and triangles ADE. Now I have 3 choices to be able to prove that the triangles are similar. Side, side, side similarity, angle, angle similarity, or side, angle, side similarity. And you can actually do this one in any of those 3 ways. Doesn't matter. So we have to decide ahead of time which way we want to do it. Okay? Which way do you want to do it? You want to do side, angle, side? Oh, it says to use side, angle, side. Okay. But you could have done it angle, angle. You could have done it in any of them. But it does, you're right. It says side, angle, side. So we have to do what it says. Thank you. So we're going to have to use side, angle, side. Now, there's also 2 ways to prove this side, angle, side. When we're talking about the angle has to be the included angle in between. So, is there an angle maybe that they share? Okay, angle what? So you're going to actually physically write, if you want to use that, you're going to say that angle A is congruent to angle A by the reflexive property. You need to physically say that. Because this is a proof. Now, it's kind of not a statement column proof, but you're actually telling me what you're thinking. So angle A is this angle here in the middle. It's the one that's shared. So we have to think about, I'm going to try to draw it a little bit bigger off to the side so you can see. Okay, so this is the angle A. right? So it's the included angle, which means that I need to now find the two sides on either side of it. I need to find these sides and these sides. You with me so far? AB and AD are very easy to find because I can just do what? I can count. Very good. So I can do that. I'm going to count the length of AB to be 1 and the length of AD to be 2. Perfect. But how do I find the length of the other sides, the hypotenuses, because these are actually right triangles? What would I do? Okay. Not if you're going to use angle A. Okay? So listen to what she asked, because, and that's why I said, which angle you're going to start with first. If you're going to use angle A as being congruent to itself, you have to use both of the sides on either side. Dina wants to be able to count the length of CB and ED. I agree. Those are countable. They're easy to find. I could find those lengths, but I can't use angle A because that would be ASS, wouldn't it? So if you're going to use angle A, and we'll come back to your way, and I'll show you how to do it your way in a minute, okay? Because you can actually do it your way. But you can't use angle A. You have to use a different angle. Let's go ahead and find the length of AC. And let's find the length of AE. Because that's one way to do it. And then we're going to show that the ratios are the same. So AC, you want to do it with the Pythagorean theorem? To me, it's a little easier. 1 squared plus 2 squared. Square root of 1 squared plus 2 squared. Isn't that just the square root of 5? Okay. And then AE is going to be 2 squared plus 4 squared. And what's that going to be? 4 plus square root of 20. And all we're really trying to do is show the ratio, so I don't need to worry about reducing the radical or anything. But 1 over the square root of 5, is that the same as 2 over the square roots of 20? So let's divide them. 1 divided by the square root of 5. And then 2 divided by the square root of 20. They're the same, aren't they? So 0.447 is the same as 0.447. Therefore, the sides are proportional. So to be clear, if you're going to use angle A, because it's the shared angle with both of the triangles, you need to find the lengths of the other sides on either side of that angle. Here's what you need to do to get full credit. You need to say the angles are congruent by the reflexive property. You need to be clear about the lengths and use these letters so I can tell which sides you're trying to find. We were trying to find AB and AC. We were trying to find AD and AE. Okay? That would get you full credit, 100%, because you've shown me everything you need to do. You've even said the word, sides are proportional. You need to say those words. Your work is important, but your explanation is important too, to get a complete answer. Now, what if you wanted to do it Dina's way? She doesn't want to do the distance formula, okay? Because, you know, that's for the birds. I don't want to do it that way. Is it possible to do it a different way? Sure. So let me redraw what I would do as the other method. I'm going to draw it bigger over here just so you can kind of see. If I just wanted to find the lengths of these, what would the included angle be in this case? The right angle. How do I prove using coordinate geometry that the angles are right? How do I prove using coordinate geometry that the angles are right? Perfect. I have to use slope and prove that the lines are perpendicular. Okay, so that's fine. Let's do that. I'm trying to show that AB is going to be perpendicular to CB. What's the work involved in showing that? What's the slope of AB? What's the slope of a horizontal line? 0. What's the slope of CB? What's the slope of a vertical line? Undefined. That is enough information for me to say that the lines are perpendicular. You told me the slopes, you've used context, you've used your letters, you've been very clear about which lines I'm talking about. The slope is 0, the slope is undefined. Well, that just gave me this angle as a right angle right here. I'll color it in. Don't I have to do the other one? So come over here. And now I'm trying to show that AD is perpendicular to AB. No, sorry, wrong one. AD is perpendicular to ED, right? The big triangle. I'm trying to show this other angle over here in the bigger triangle is a right angle. So what's the slope of AD? 0. What's the slope of ED? It's undefined. That is enough information to show me that the lines are perpendicular. But just like in a 2-column proof, perpendicular is not enough. What do I have to now say? Perpendicular lines form right angles. And all right angles are congruent. And which angles are the right angles? Angle ABC is congruent to angle ADE. All of that work is necessary to just show that the two right angles are congruent. Okay? But now I can just count to find the legs. Now it's easy. Now it's cake. Now I can just say, okay, I've got the angles are congruent. So I could start right here on the other way and just say, boom, the angles are congruent because they're shared. Done. But there's a little bit more work in showing the sides are proportional. Over here, a little bit more work showing the right angles are congruent, right? But now that the sides are proportional part should be quick. So I need to now say, in this picture, that AB over BC, so AB over BC, is the same as AD over DE. I'm showing that the sides are proportional. So I'm going to show that AB over BC is the same as AD over ED. I'm trying to show that. Look at the context I'm using. Look at what you're communicating to me what you're doing. I'm going to use the letters, and now I'm going to put in the numbers. What is the length of AB? 1. What's the length of BC? 2. What's the length of AD? 2. What's the length of ED? 4. Sides are proportional because 1/4 and 1/2 and 2/4 are the same. So either way you do this problem is okay. The left-hand side is one way, and then the right-hand side is another. But in order to get full credit on this question, you have to do everything on one of the sides. All the work, all the steps. I don't think any of us had done all of that. Let's just say it was close. Are we clear about what I'm expecting on the test, though, now? You sure? Y'all are really quiet today. It's bugging me. What's up? It's because you don't see me first thing in the morning now? You act all weird? Come on. What's up, Mamo?
A little tired.
A little tired? Tired? Come on. I had coffee this morning. I'm not tired. Thanks, Kara. You rock. Had some caffeine. I'm ready to go. All right. I think we should review a little bit more. Want to talk about the sections of the test and that kind of thing? So I have to ask Jared and, I should say, to move up with Ashley and Jason. Everybody else has at least 3 people at their table. Kira, you want to be my scorekeeper? Perfection. Okay. And if each table could go back and get 1 dry erase marker, 1 board, and 1 eraser for me. So the test is going to be tomorrow. While you guys are getting your supplies for the review, here's the homework. Okay, so here is the review. That's your homework. Okay, take a picture of it if you want. I'll text it to you soon as well. But let's talk about the sections of the test and what you can expect. Okay? So, on tomorrow's test, there are 5 sections. The test review in the packet in the back of your book, the back of your similar packet, was not comprehensive because what it didn't have on it that is going to be on your test is the similar solids stuff. Okay, so you're going to have a whole section of your test that's just going to be on similar solids. Okay? That's where you have the ratio of the sides, the ratio of the areas, and the ratio of the volumes. And those first few problems on the review that I put up here, these are on similar solids. Okay? So you should work on that. Yesterday afternoon, we worked on some problems like that too during the after-school review. The next thing you guys are going to have to do is you're going to have to prove similar triangles. That could be using coordinate geometry like we just did. That could be using an actual proof, like a 2-column proof. Okay. What additional information would I need to show, that kind of thing. You're going to have to be able to use similar triangles to solve for x. You're going to have some problems where I say this triangle is similar to this triangle, therefore solve the problem. So you'll have to use the similarity statement and figure out what matches to what and solve for x, usually with a proportion. You also have applications or real-life example problems. So I'll just say real-life problems, which means like the shadows of the trees, the mirror problems, trying to find the height of the flagpole, kind of like we did. It's also a lot like that first quiz that you took on ratios and proportions, where if you guys remember, the box of toothpicks held this many, and then you doubled the thing, it held this many, that kind of stuff. Or in your the quiz, I think it was like the number of girls that were juniors and the boys that were juniors and that kind of problem. What else would it be? Maybe like on a map, a scale factor is 1 inch equals 100 miles. Measure the distance and tell me what's the distance from Mexico to New Guinea. I don't know, whatever. Okay, those I don't know where that came from. Anyway, real life example problems. And then the last thing, and these are not necessarily in any order. They're not going to be in this order on your test, but they're just the sections. Would be the similar right triangles. That's like the geometric mean stuff. Okay, so I'll just draw an example so you know what I'm talking about. But when you have this guy, you had to find. Okay, so that's going to be all the different sections of your test. I have gone ahead, and you can take a picture, that's fine. I've gone ahead and created a little Jeopardy section for you guys. When I played it with my 6-block class, a couple of the questions got out of order from the category. I'm not sure how to fix that right now. So if you pick a category, it might be for a different question. So sorry about that. But anyway, we'll do it anyway. Okay? So again, your homework is going to be this. You'll turn both these problems and the test review in the book tomorrow. Okay? All right, let's go ahead and play.